Hello, Vijay here again at SST. About to discuss with you a few of the advanced features in CheckStress. CheckStress is a quick pipe stress check application for piping systems designed inside AutoCAD Plant 3D or any CAD platform that produces PCF files. If you have not watched the introductory video, I strongly recommend that you do, because I'll give you a quick summary of what this software can do for you. Here's a 30-second summary of it. CheckStress can import lines that you extract from AutoCAD Plant 3D and analyze them for basic code compliance issues. When I say basic code compliance, I'm talking about expansion stress like the one you see here, or sustained stress like the one you see now, and tells you whether this piping system will pass code compliance or not. Anything red means fail, anything blue means pass. That's as simple as it is. So on to the advanced features. Now let's say you're a designer and you have been tasked with identifying those lines that require further stress analysis. The first step would be to use CheckStress, and you would run those lines through CheckStress, and if you see a blue, it will pass. If you see a red, then it won't pass. Now at this point, now you have two choices. One, you can simply send this file over as a kpipe file or a CZ2 file here for further stress analysis by the stress engineer, or since you already have access to the GA drawings, you might as well play around a little bit by adding a few supports and then see if it makes a difference to your line. There are two ways you can do this. You can go back to AutoCAD and then make the changes there, re-extract the PCF file, come back here, and then run it through CheckStress, and it will tell you whether it's red or blue. Now assume that you don't want to go back to AutoCAD for whatever reason. It's just a little bit more cumbersome than this software, and you would rather be done here quickly by making a few edits. Now let's say this is the line that you want to see if you can do anything here to make this work. So you go to Edit Layout and you click on this element. Obviously, as you see here, there is no support in the system along this long horizontal run. Now let's say you divide this based on your GA drawings, that you have some steel approximately 50 feet apart. So let's put two supports 50 feet from this point here and another 50 feet from this point, which is here. So how would you do that? Click on the element, and that tells you the highlight here shows you where that element is. And let's first change the units to all English, and now you know it's about 150 feet or 145, but let's round it off to 150. Now you can make 2 points here. You can use the edit command, say split this element. Let's make a node 4601 at 50 feet from node 460, and you get your first point. And continue on, and you have another element here. Or let's go back to 4601, and let's say you want to put a rack support, which is called a limit stop. Make it a vertical limit stop. Everything is, we just click that button and it puts a limit stop, and you can see that appear here. Now you want to put another one 50 feet away from this first limit stop. So split the element again, come here, split 50 feet, sorry, that's 4602, the node number, at 50 feet, and click OK, and the other node is made. Now here you want another limit stop. You did that, make it vertical, and click OK. Now you will see that there are two supports here that you have input. There is one, and here's the other one. Now you want to see quickly whether this helps your case or not. So just go ahead and analyze this, and look at the expansion stress. Of course that didn't change, but let's look at the sustained stress. Did that change? Looks like it did make a difference. Adding two supports here, equally spaced 50 feet apart, did make a difference, and everything is in the acceptable zone. Anything red means the ratio is 1.0 or higher, which means code compliance will fail and not pass code compliance. Now let's see if we can find out whether these supports are really active or not. Now, status of resting support here will show you in the operating case, if you see reached and reached, that means these two limit stops are active. Whereas if you were to look at expansion case, the one at 4601, which is this one here, we can turn the node numbers on if you want. Say node numbers on, 4601, 4602, and I'm going to do a selective nodes here, branch points, limit stops, and by looking here you can see that in the expansion case the pipe is actually lifting up. That's what the not reached would mean. And this one, it is not lifting up, it is resting on the support. So you have blue in the expansion case, and the sustain case you have another blue combined with greens, or which is anything under 1.0. And now if you want to send this all over to the stress engineer, you can just save it as a kpipe model file or a CS2 model file, and you're done. And there are more advanced features, but we will reserve that for another video. So here's a summary of what we just did. We took a single line from AutoCAD Plant 3D as a PCF file, ran it through CheckStress, and looked for basic code compliance issues by studying the stress ratios. And what do we mean by studying? I simply mean, is it red or blue? If it's red, then there's cause for concern. If it's not red, it's okay. It will pass code compliance. So that's it for this video, and let's see if we can make another video with more advanced features. Thank you for watching.